story about achieving production-grade infrastructure in under 5 minutes. This is a story about achieving production-grade DevSecOps in under 5 minutes. This is a story about achieving total convergence of GitOps in under 5 minutes. This is a detailed review of how GitLab's 5-minute production was built from the ground up. My name is Shri, and from November 2020 till January 2021, I worked closely with GitLab co-founder Dimitri in building 5-minute production. Five-minute production blends solutions offered by AWS, HashiCorp Terraform, and GitLab together and offers production-grade development workflows. We start with your GitLab project, which has the source code for your web application. Regardless of which language or framework you use, your web application is packaged as a container image and stored within your GitLab project's container registry. This is the build stage. Then comes the provision stage, where Terraform scripts connect to AWS and create a secure environment for your web application. The environments provisioned relate to your Git branching workflows. Long-lived Git branches create long-lived environments, and short-lived Git branches correspond to short-lived environments. Resources provisioned include Ubuntu VM, scalable PostgreSQL database, a Redis cluster, S3 file storage, and more. We consider these elements as the building blocks for majority of web applications, and many of these fall under the free tier of AWS. The infra state and credentials are stored within your GitLab project's managed Terraform state. Finally, we have a deploy stage, which retrieves the deployable package from the GitLab container registry, retrieves the infra credentials from the GitLab managed Terraform state, and proceeds to deploy your web application. You get all of this by simply including these two lines in your .gitlab CI YAML file. Let's look at the complete process in more detail. The build stage is where it all begins. 5-minute production reuses the auto build job from the GitLab's Auto DevOps pipeline. Auto build builds and packages web applications that are containerized with a Docker file, or compatible with cloud native build packs, or compatible with Heroku build pack. Thus, web application across multitudes of technologies are supported, including web frameworks such as Rails, Django, Express, Next.js, Spring, etc., and programming languages including Python, Java, Node.js, Ruby, Clojure, etc. Once the auto build job has finished execution, we have newly created container image stored in your project's container registry as an artifact. The next step, provision, prepares infrastructure resources in AWS. The first step here is the presence of AWS credentials stored as CI/CD variables at the project or group level. Once valid AWS credentials are found, a Terraform script is executed to generate resources in AWS. These resources include an EC2 virtual machine based on Ubuntu 20.04 LTS, PostgreSQL database managed by AWS RDS, Redis cluster managed by AWS Elasticache, S3 bucket for file storage, email service credentials managed by AWS SES. Out of these resources, the critical resource is the PostgreSQL service, for which we have daily backups enabled. PostgreSQL data is snapshotted if the infrastructure resource is destroyed through a manual user action or via the 5-minute production pipeline. The EC2 VM is the only service accessible publicly. Ports 22, 80, and 443 are exposed. Every other resource described above is part of a secure virtual private network hidden from the public web, accessible only via the EC2 instance and of course your web application that is deployed there. Do note, these are stateful services and the environments are coupled with your Git branches. This means every Git branch creates a new environment with these resource sets. We don't have a preference on your Git branching and environment's lifecycle. Use long-lived or short-lived branches as you see fit. Just keep in mind that long-lived branches lead to long-lived environments and short-lived branches lead to short-lived environments. Finally comes the deploy stage. This is where the deploy script retrieves your web application container image from the GitLab container registry. Then it retrieves the EC2 instance credentials from the GitLab managed Terraform state and proceeds to deploy the relevant version of your web application in the relevant environment. Do note that modern web application might require additional commands to be executed after each deployment or after the first deployment, and these commands can be defined as variables in your .gitlab CI YAML file. Finally, with the help of certbot from Let's Encrypt, SSL certificates are generated and configured for your web application. If you have defined the cert domain variable, the SSL certificate will be generated for your custom domain name. Else, the generated SSL certificate uses a dynamic URL that 5-minute production prepares for you. There we have it, a simple yet production-ready setup for your web application. If you are looking for an AWS-based setup, this is ready for usage. If you are looking for something similar but not quite 5-minute production, this serves as an example of how to converge infra as code with software development and provide seamless, continuous deployment workflows. In my personal experience, this is one of the most complete example of GitOps. Your application source code lives inside your GitLab project. Your infrastructure defined as code lives inside your GitLab project. Your CI/CD pipeline lives inside your GitLab project. Your infrastructure state lives inside your GitLab project. Your infrastructure secrets and credentials live inside your GitLab project. And your environment configurations live inside your GitLab project. Go ahead, give this a try, get inspired, and have a nice day.